Now that we have looked at the IT spine of the project, I'm going to tell you something about the applications that Healthy Child has developed over the past 4 years. There are 3 distinct types of applications that we have developed. The first are generic tools for basic data entry work across all the disease areas of Healthy Child. The second are applications that go beyond data visualization and analyze the data. And the third are applications which have been specifically designed for each of the 3 disease areas studied in Healthy Child, and these are applications that perform more complex work. Momentarily, we will look at specific examples of these, not going into extensive detail, but merely summarizing some of the highlights of Healthy Child in terms that are meant to elucidate more than educate. Let's listen in the first instance to David Mancé speaking about the variety of applications that have been produced.
But as you can see, it's about 16 applications that were developed in the project, ranging from simple authentication and connection to the system to already complicated data acquisition and integration interfaces, to then support the more advanced querying tools for similarity search, patient comparisons, knowledge discovery, and then finally all the physiological models sitting on top of the platform.
Let's now look at one of our generic tools. The Healthy Child application suite provides a number of ways to visualize information related to an individual patient or group of patients. The Visual Patient Browser application provides browsing capabilities across the patient sets that are available throughout the Healthy Child system. What browsing capabilities means is easy to understand when you think of many browsing paradigms that any computer user is familiar with, like web browsing or folders browsing on your computer. Healthy Child also takes advantage of a number of visualization tools which are not so common. Tree maps along with neighborhood graphs and heat maps make up a stable of novel visualization tools that Healthy Child has made available to the clinicians and researchers through 3 applications. One is the Case Reasoner, which we will look at in more detail shortly. The other 2 applications are the Semantic Reasoner and the Visual Patient Browser applications. The combination of the Visual Patient Browser and tree maps employs the full range of the feature set of Healthy Child's toolkit. We shall therefore use this combination to demonstrate some of the functionalities of Healthy Child's data visualization tools. The tree map concept allows for a space-filling representation of a data set where the records are each represented by a rectangle filling the space. This approach was utilized to give clinicians a more intuitive and powerful way to visualize the data, to present the patient information in a browser interface that is intuitive, that is customizable, and that the clinicians can play with and present hierarchies and navigate them with the goal of doing data mining. The main goals behind the tree map applications are to present the patient information in an intuitive browser interface, to provide the user with flexible views that are on-the-fly, customizable, and data-aware, to employ state-of-the-art visualization paradigms for advanced presentation of patient cohorts. To achieve these goals, the tree map paradigm is based on using a number of graphical clues to enhance the simultaneous visualization of multiple records as seen in this image. It also does this in a way that the space available on a screen is used efficiently, so that a large number of records can be displayed at the same time. To make better use of the tree map approach, we have enabled this tool to make use of semantics. As Thomas Hauer from the University of West England explains,
Let me start with an example. Let's say that you have a simple view of the data set. You have patients and you have some attributes, some of which are labels, some of which are numeric attributes. And you have some kind of visualizer or maybe the crazy reasoner application that already knows how to deal with numeric attributes. You can define distance functions or you can define classifications. But some of the attributes are inherently such, in this example, the tumor site, where a lot of implicit semantics is required to actually interpret what is in the data set. For example, in this case, if you want to define a distance function between patients according to the tumor site, then you would be in trouble because you cannot capture the real characteristics of the patients unless you actually know the meaning of these words. So this is where annotation with explicit semantics will help. So in order to actually use the meaning of those attributes that cannot be interpreted without explicit semantics, you have to have some kind of background knowledge represented in an ontology that is used to annotate that data set. And in turn, you have to use that ontology to achieve some kind of classification, or you have to have the computer to do the classification for you.
To add semantics, clinicians have made a large number of medical ontologies available, which have been derived from annotating and validating the images that we're collecting during the Healthy Child clinical studies. Expliciting semantics provides many benefits for medical applications in the fields of information integration, classification, browsing, and reasoning. We have found that tree maps work well for visual data mining, as clinicians have found them particularly intuitive and good at displaying large numbers of patients.